This video covers the concept of refraction. So here we have an interface, which is the space between two media. Let's assume that medium 1 is a medium where waves can travel through quickly, like air. And medium 2 is a medium where waves travel through more slowly, like glass or water. So we have a white light wave traveling from the fast medium to the slower medium. Let's assume that the wave fronts for the wave traveling through the fast medium looks like this. This means that the wavelength is the distance between two consecutive wave fronts. When the wave then travels through the slower medium, the wave fronts become closer together, and the wavelength shrinks. So when a wave travels from a fast to a slow medium, the wavelength and the velocity of the wave decrease, while the frequency stays the same. A good analogy to why this happens is to compare wave fronts to lines of people in a marching band. Assuming the marching band is traveling on concrete through one medium, which would be a fast medium to travel on, the lines continue to stay evenly spaced until they interact with a second medium. Let's assume that at the interface, the marching band begins to walk through thick mud. This will slow down the people in the marching band, and they will end up getting closer together, like the wavelength decreasing, and they will travel slower, like the velocity of the wave decreasing. But the number of people that are in the marching band will not decrease, which is like the frequency. Hopefully this clarified the concept. Let's move on. So let's assume that we have an interface between a fast and a slow medium. A wave of light hits the interface at an angle with the wave fronts that are this far apart. One would assume that the light travels straight through the medium, but this is actually false. The light actually ends up bending towards the normal line. So if a wave travels from a fast to a slow medium, the wave bends towards the normal line. The wavelength also decreases, so the wave fronts through the second medium will become closer together. So if we compare lambda 1 and lambda 2, we find that lambda 1 is greater than lambda 2, which tells us that the wavelength decreased. Now let's look at what happens when the wave travels from a slow to a fast medium. One would assume that the light would travel straight through like this, but we know that this is actually not the case. Instead, the wave tends to travel. So when this happens, when a wave travels from a slow to a fast medium, the wave actually bends away from the normal line and looks like this.